Hello everyone and welcome back to the A+ Tutor. Today we're going over solving word problems using similar polygons and scale factor. A 6-foot tall tent standing next to a cardboard box casts a 9-foot shadow. If the cardboard box casts a shadow that is 6 feet long, then how tall is it? So if we visualize this, we have a tent. I'm going to do a rough sketch of a tent that is 6 feet tall. This tent, with the sun shining on it, casts a 9-foot shadow. So if we have a box that casts a 6-foot shadow, we want to know how tall is it. So what we can do here is we can actually use proportions to solve this. If we know that a 6-foot tall tent casts a 9-foot shadow, then an X-foot tall box casts a 6-foot shadow. So using this proportion that we set up, we can solve for how tall that box is because we know that it's going to be proportional to the shadow. So we'll just cross multiply. 6 times 6 is 36 equals 9x. We'll divide both sides by 9 and we're left with x equals 4. So the box is 4 feet tall. A telephone booth that is 8 feet tall casts a shadow that is 4 feet long. Find the height of a lawn ornament that casts a 2-foot shadow. So we've got a telephone booth that is 8 feet tall, and we have a short shadow that's 4 feet long. Then we have a lawn ornament whose shadow is 2 feet, and we need to figure out how tall it is. So again, we're going to do the same thing. We're going to set up a proportion to see the height of our lawn ornament. So for the 8-foot tall telephone booth, we have a 4-foot long shadow that's going to be equal to the X tall lawn ornament, which has a 2-foot long shadow. So we just want to make sure when we set up this proportion that we are staying consistent with what's in the numerator and what's in the denominator. We'll cross multiply and we'll get 16 equals 4x. Divide both sides by 4. And x is equal to 4 feet tall. So our lawn ornament is 4 feet tall. A map has a scale of 3 centimeters to 18 kilometers. If Riverside and Smithsville are 54 kilometers apart, then how far apart are they on the map? So on a map, for every 3 centimeters that we measure, that represents 18 kilometers. If we have 2 points on this map, and we know that the distance between them is 54 kilometers, we want to know how many centimeters that is on our map when we're actually looking at our map. Let's set up a proportion to figure this out. So for every 3 centimeters, that represents 18 kilometers. So for every x centimeters, which is what we're looking for, that's 54 kilometers. So we want to find exactly how many centimeters that is. We can cross multiply and we'll get 3 times 54 is 162 equals 18x. If we divide both sides by 18, we get x equals 9 centimeters. So we know they're 9 centimeters apart on the map. If we didn't want to set up a proportion to solve this, another way that we can solve this is taking that scale factor, which is 3 cm over 18 km. Basically, what you would do is you would put whatever it is you're looking for on the top for our scale factor. So we're looking for centimeters, so we want our centimeters on top. And then you're going to multiply by whatever's going to cancel out the value that you're given. So in this case, we're given 54 kilometers, so we're going to multiply by 54 kilometers. So our units, our kilometers will cancel, and we're only left with centimeters. And then when we solve this, 3 times 54 is 162 over 18 is 9, and we're left with centimeters. But if, let's say, we were given the 9 centimeters and we had to figure out how many kilometers that was, then we would just do the opposite. We need kilometers, so we would do 18 kilometers over 3 centimeters times our 9 centimeters that were given. Those centimeters would cancel and we'd be left with 54. So you can always just multiply your scale factor by your unit. You just want to make sure you're keeping track of how our scale factor should be written, and then you're using the units as a guide to solve for what you're missing. Here's another map problem. Find the distance between Riverside and Milton if they are 12 centimeters apart on a map with a scale of 4 centimeters for every 21 kilometers. So again, we have a map, and on the map, these two cities are 12 centimeters apart. So we need to figure out how many kilometers apart they are. So in the last problem, I just told you that we can use our scale factor and just multiply that by whatever we are given. So let's try it that way, and then we'll prove it with our proportions. So if they're 12 centimeters apart, we have 12 centimeters. So that means I need my centimeters on the bottom of my fraction so that I can cancel those out. So for my scale factor, my 4 centimeters goes in the denominator and my 21 kilometers goes in the numerator. So now my centimeters will cancel and I'll be left with kilometers, which is the unit that I need. 12 times 21 is 252 over 4. And then when we simplify that, we get 63 kilometers, which is how far apart these two cities are. So now if we set up our proportions and do the same thing using our proportions, we would have 4 centimeters over 21 kilometers equals 12 centimeters over x kilometers. We'll cross multiply. So 4x equals 12 times 21 is 252. When we divide both sides by 4, we get x equals 63 kilometers, which is what we found using our scale factor. So use either way that you're comfortable with. If you prefer just multiplying by the scale factor, do that. If you prefer setting up proportions, do that. But you'll get to the same answer either way, as long as you're doing it correctly. A model house is 12 centimeters wide. If it was built with a scale of 3 centimeters for 4 meters, then how wide is the real house? So our model house is 12 centimeters wide. And then we have our real house, which is x meters. So let's multiply by our scale factor, and then we'll do our proportion to show both ways. So first, let's start with our scale factor. So we have 12 centimeters, and we need meters. So we're going to multiply that by 4 meters over 3 centimeters. So we'll flip our scale factor. Our centimeters will cancel. 12 times 4 is 48 over 3. And 48 divided by 3 is 16 meters. So our house, our real house, is 16 meters wide. Now if we set up our proportions, we'll get 3 centimeters over 4 meters equals 12 centimeters over x meters. So we'll cross multiply. We get 3x equals 4 times 12 is 48. Divide both sides by 3. And x is equal to 16 meters, just like we found before. So we get the same answer. Oak Grove and Salem are 87 miles from each other. How far apart would the cities be on a map that has a scale of 5 inches for every 29 miles? So in real life, they're 87 miles from each other. So we want to see what that looks like on a map. So let's use our scale factor. We have 87 miles. So we need to put our miles in our denominator so that we can cancel. And we need to be left with inches, so that goes in our numerator. And our miles cancel. 87 times 5 is 435. 435 divided by 29 is 15 inches. So they would be 15 inches apart on the map. Now let's set up our proportion. 5 inches for 29 miles equals x inches for 87 miles. We cross multiply. 5 times 87 is 435 equals 29x. Divide both sides by 29, and we get x is equal to 15 inches. Same answer. So we know that they're 15 inches apart on the map. A particular car is 18 feet long. A model of it was built with a scale of 4 inches for every 3 feet. How long is the model? So the actual car, and I'm just going to draw a box to represent the car, is 18 feet long. Our model then is how many inches? Using our scale factor, we have 18 feet, so we want to multiply that by 4 inches over 3 feet so that our feet will cancel. 18 times 4 is 72, divided by 3. So when we divide 72 and 3, we get that our length of our model car is 24 inches. When we set up our proportions, we'll do 4 inches over 3 feet equals x inches over 18 feet. So we cross multiply. 4 times 18 is 72 equals 3x. Divide both sides by 3, and you get x is equal to 24 inches. So our model car is 24 inches long. A particular house is 12 meters wide. A model of it was built with a scale of 4 centimeters for every 2 meters. How wide is the model? So we know the real house is 12 meters wide. We need to find how wide in centimeters our model is. So let's use our scale factor. We have 12 meters. We're going to multiply that by 4 centimeters on top because we need centimeters, and 2 meters on the bottom because we want to cancel our meters. 12 times 4 is 48 centimeters over 2, which is equal to 24 centimeters. So our model home is 24 centimeters wide. When we set up our proportion, we'll do 4 centimeters over 2 meters equals x centimeters over 12 meters. Cross multiply. 48 is equal to 2x. Divide both sides by 2. And we're left with x equals 24 centimeters. A man that is 5 feet tall casts a shadow that is 4 feet long. Find the length of the shadow that a 15-foot adult giraffe casts. So our man is 5 feet tall, and his shadow is 4 feet long. If we have a giraffe that's 15 feet tall, how long is this shadow? So we'll set up our proportion. Our 5-foot tall man casts a 4-foot long shadow, which is equal to a 15-foot tall giraffe, which casts an x-foot shadow because we don't know. We'll cross multiply. So 5x is equal to 15 times 4 is 60. Divide both sides by 5. And we're left with x is equal to 12 feet long. Sun Valley and Johnstown are 10 centimeters apart on a map that has a scale of 2 centimeters for every 11 kilometers. How far apart are the real cities? So again, on a map, we've got our 2 cities that on the map are 10 centimeters apart. So we want to know how many kilometers apart they are in real life. Using our scale factor, 10 centimeters times, we want to get rid of our centimeters and be left with kilometers. So we're going to do 11 kilometers on top over 2 centimeters in our denominator. Our centimeters cancel. 10 times 11 is 110 kilometers divided by 2, which is 55 kilometers. When we set up our proportion, we have 2 centimeters over 11 kilometers equals 10 centimeters over x kilometers. We'll cross multiply. 2x is equal to 110. When we divide both sides by 2, we're left with x equals 55 kilometers. These are our last two examples for this video. A model igloo is 15 inches wide. If it was built with a scale of 5 inches for every 4 feet, then how wide is the real igloo? So we've got a model igloo, which I'll just represent with a box because I can't draw an igloo, is 15 inches. So the real igloo is going to be how many feet? Let's start by using our scale factor. We have 15 inches and we need to be left with feet. So we'll put our 4 feet on top over our 5 inches in our denominator. Our inches cancel. 15 times 4 is 60 over 5. And 60 divided by 5 is 12 feet. So our igloo is 12 feet wide. Let's do the same thing and set up our proportion. 5 inches for every 4 feet is equal to 15 inches for every x feet. When we cross multiply, we get 5x equals 4 times 15 is 60. Divide both sides by 5. And x is equal to 12 feet. And last, we have a baby giraffe that is 6 feet tall casts a shadow that is 15 feet long. Find the height of a bird bath that casts a 10-foot shadow. So we have a giraffe that's 6 feet tall, and it casts a 15-foot shadow. Our bird bath, we don't know how tall it is, but we know that it casts a 10-foot shadow. So let's set up a proportion. 6 foot tall, 15-foot shadow equals x feet tall and a 10-foot shadow. So if we cross multiply, 6 times 10 is 60 equals 15x. Divide both sides by 15, and we get x equals 4 feet tall. Thanks for watching. I hope you learned something. If you're not subscribed to my channel, make sure you subscribe, and if you like this video, give it a thumbs up. Leave any topics you'd like to see in the comments below. See you next time.